I'm Bob Sandheinrich. I'm going to be talking about the function repository and resource functions, new in version 12. I'm Bob Sandheinrich. I'm a developer here at Wolfram. And for the next hour or so, I'm going to be presenting on resource function and the new function repository, and also briefly talking about other repositories. So here's a brief agenda. First, I'm just going to recap, hopefully, for most of you, what a resource object is and what we mean by repository in this context. Then we'll briefly go through the two repositories that we've already released, the data repository and the neural net repository. And then we'll spend the large chunk of the talk on the function repository and resource functions. And then real quickly, we're going to, I'll demo the formula repository. And then I'll just show a quick list of things that we're going to be working on in the future. So hopefully some of you have used resource objects already for either the data repository or the neural net repository. In the data repository, they're sort of upfront, so you probably would have encountered something like this. And what a resource object is basically it's just a wrapper around metadata. If I open this guy up, you can see that there's a lot of keys and values displayed in this summary blob. It's a wrapper for metadata, but it also points at content. And in all cases, the content in these resource objects is something that's immediately designed to be used in the Wolfram language. So for data repository, the content is data. We can look at the content of this guy real quick if we want. It's a 3D model. We consider data to be basically any static expression in the Wolfram language. For the neural net repository, it's neural networks. For the function repository, the content is functions. But they're all things that you can access via a resource object and use immediately. And so once we've sort of put in a bunch of effort to curate a lot of good examples of a specific content type, we bundle those up and publish what we call a repository. So when we make a repository, we make a website for it, we make it searchable, we break things down into categories, and we hook it up into top-level functions for you to use. So the first repository was the data repository. It came out in 2017. We can look really quickly at the website. You'll see here all the resources are broken down into different categories. And the important thing to note is each one of these things, if we just pick one, each one of these things has its own web page where it has its name, a brief description, and goes straight into examples. And all of these examples are things that you can copy and use immediately in the Wolfram language. You just click on an example, and you go back and you paste it in, and it works right in the resource, in the notebook anywhere. Here's another one I copied just for an example of a data set. Like we saw on the previous page, they're not all data sets. The previous page had a 3D graphic object. So it can be a graph network. It can be audio. It can be sort of, like I said, any static expression we can treat as data in the data repository. And this is just an example I used of doing some analysis on that meteorite landings resource. And this is straight off the web page. So what separates our data repository from the myriad others that you'll find online is that it's actually useful. A lot of times, it's just a place for people who publish things to say they've released their data without the intent of anybody actually using it. So if you can track down the PDF that has a graph in it, it's not really useful. Sometimes it's a spreadsheet. Sometimes it's something, some JSON or something useful. But none of them have these examples that you can immediately compute with and know how to use. So the second repository we released is the neural net repository. If you were at the tech conference last year, you probably heard about us. So you're saying, come on, that was 2017. Well, that was sort of ended up being a sneak preview. After the conference, we decided there was a little more content we wanted to get in, a little couple more features we wanted to get in before we really went loud in public with it. So that ended up happening in early 2018. And that we can again look at the website briefly. This one, instead of having it broken into categories on the home page, it's all the neural networks are just listed here. Probably we're gonna have to do something about that soon. It's getting to the point where scrolling is untenable. So we might see something move towards the data repository design before too long. But if you've managed to avoid neural net talks so far at this conference, I am amazed. So I'm not gonna spend too much time on our neural networks. You probably already know that they're outstanding. One thing that'll sort of motivate talks later on, here's a colorization net that takes a grayscale image and colorizes it. And this is a little utility function that's on the web page for this net and a few other nets that sort of help you take the raw inputs and outputs from the net and create sort of a function that even someone as simple as me knows how to use. So let's print out the gray one there too. So there's color and gray, and then we can see how this net does it, turning it back. All right, so it thinks this is sort of blue behind me instead of red. That's interesting. So this is sort of packaging up of the raw net into easy to use functions. It's something that once we had these nets in the repository, we did for you in a lot of cases, like image identify and image restyle. These are all things that have neural networks under the hood that are distributed by the neural net repository using resource objects. And you may have used them 100 times and not ever realized that you were using resource objects. But that's the empowering technology. So now the third repository that we're publicly announcing is the function repository. And that's happening right now. Stephen talked about it in his keynote on Tuesday. And Rick mentioned some stuff in his talk yesterday. But now we're spending more than a couple minutes on it, really getting into some details. So let's start off looking at the website again. So these are the initial set of published functions. You can see sort of like neural net, we've just started by just listing them on the home page. We're going to sort of see where you all want to take us with the content before we try to categorize the entire world of computation. Each one, just like before, each one of these has its own page where there's a name and a description and examples that you can use right away. We've added a couple more sections here to make this look just like almost just like the documentation notebooks that you're probably all very familiar with. So we have these usage boxes and the details and options. And all this stuff is click to copy. So you can click here and copy it. I'm going to grab one of these examples. If I go back to my notebook, I can put it in. It'll work right away. I'm going to do a few more of these just to make it more fun. Let's just play with some numbers. I don't even know how big this monitor is. We'll live dangerously. All right, here we go. No hands. All right. Okay. So this seems like something that's sort of frivolous and silly. Maybe it is. But yeah, that's good for a function repository. Plus, there are real applications. Like we internally do a lot of like interface testing. So this is something that you could use to sort of automate moving mouses to precise locations and clicking to make sure that the notebook interfaces don't regress. Something along those lines. So even something that's sort of fun and silly can be really useful. So brief overview of how to use one of these functions from the repository. Let's see, do I still have that here? So if I take this guy and just evaluate it, what you get back is this little pill-shaped blob. And so you can put this anywhere in your code. So if I do something like move up of X, I guess I didn't quit after I practiced last time. So then I could do something like this. Let's go, hold on one second. What was it on the last slide? Maybe get that guy. Can't remember things like that. And I think this is negative. I think the top of my screen is, so here's this guy. We got move up, and we can say move up of 300. There we go. All right, so you can stick these little resource function blobs straight in your code anywhere, and they'll work whether you're in cloud or desktop, assuming you can access our cloud. If with an internet connection, you don't even need to log in. So that's how you can sort of use one of these things. Also, these, like I said, resource objects inherently have metadata. So you can get the properties of these things. You can wrap it in resource function again and say something like description. And it'll get that. Probably a better, more useful thing is you can say example notebook. And this will pop open the same examples that we saw on the web page in a nice notebook that you can evaluate on your desktop or cloud if you're in cloud. All these examples will just work anywhere. And another important thing to note is that you can go back and forth arbitrarily between resource objects and resource functions. So resource object of the resource function gives this guy, which hopefully we're somewhat familiar with, and then you can go back to resource function. So this is useful because resource object sometimes is a more useful workflow for looking at the metadata of the resource, whereas resource function is what you'll actually use to apply the function to things. So that's sort of the most basic use case. So sure, go ahead. We're going to get there. Hang on tight, OK? All right. So the next thing we're going to look at is defining your own resource function. And there are a couple ways to do this. The fastest and easiest way is using define resource function. So this is a new symbol in 12. So I'm going to define something called put a bird on it. So first I need to get a bird. I'll use web image search. That's a cute little bird. But it's a little bit too big to put on everything, so we'll make it smaller. And we'll define this function, see that it works. OK, so there's a function. And now I'm going to turn it into a resource function. So here's my blob, and I can say put a bird on it. Everybody likes to do plot. This one works out well because the bird needs a little hill to perch on. So we'll give it a little hill to perch on. There we go. So just a fun little thing. So you can define a resource function just like that real easily. So before we move on much further, I'm going to get into some of these details about the nuts and bolts of resource functions. So the definitions are imported into the resource function when you evaluate define resource function. So if I have f that depends on g, and I define a resource function for f. Oh, one thing I should also mention, if you notice in the last example, I just used one argument, define resource function, and the function itself was named the same thing as the symbol that I used. In this case, I'm using two arguments. My symbol is f, and I'm explicitly giving a name of f, but also g. So these definitions for f and g are included at the time I do define resource function. If I clear g, I can grab this guy, and it still works. So the definitions are maintained as sort of a snapshot. If I redefine g or f, it's still going to give the same thing because they're imported at the time. And the way this is done, if you're interested, this is totally unnecessary to know for any normal usage, but you guys are all very inquisitive. So we create a symbol, an internal symbol in this big ugly context that actually contains the definitions that the original symbol had. This symbol works just like the resource function. It works just like your original function. We'll put this back to 5. That makes more sense. All right. So that's sort of the way it's implemented is all of the dependencies are moved into a dedicated context. And those definitions are stored in the resource function, which, as we will see later, you can then export locally on disk or deploy to the cloud or any of a number of things. Does that answer your question? Okay, sir. You can. We'll get there. No, that's a great question. So another thing to know is that attributes are supported. So I think we can all agree that addition is a terrible sin, and we all want functions to avoid it. So if I make this never add function that has this hold first attribute, basically if there's a plus in there, it's gonna throw a warning. So the resource function, has the attributes are passed on the resource function. It works just the same. That's a nice thing to know. Also, these things like attributes will work right on the resource function. So you can just put in there. So here's an ugly way to see the definitions. There are prettier ways. One of which, I don't know if we published. We've published a resource function that shows prettier ways to do it. So I don't know if it's actually made it out yet, but it's in the queue if it isn't. But yeah, this is sort of a, if you don't mind looking at ugly code with big context in it, you can see it that way. You can, I guess I already showed this already. You can go to a resource object, use that to view properties as well. Since all I did was make this with define resource function, the metadata is not very filled out and very rich. One other note that's getting a bit technical, but might be important to some of you if you're planning on using this, is that resource functions are really intended to work with down values. They're expected to take arguments and give results. So if you do a lot of programming using up values on your symbols, you will run into some issues when you try to create resource functions for those symbols with up values. For example, here I made something called which_def that has an up value for plot. If plot is invoked, it returns up values. If anything else, any other single argument, it gives down values. So when I use that symbol directly, it uses the up value. But if I replace it with a resource function made from it, it doesn't. The plot works on a string, which just can give an empty plot. There are also cases where up values are used. So here I'm using list plot instead of plot, and I have a double slot here. And it turns out that just like the symbol, the resource function invokes the up value. I'm not going to spend a lot of time going into all these details, but if you think about the fact that the definitions are really in this internal symbol, you'll figure out why this happens in 5 minutes, and if not, I'm happy to explain it to you after the talk. Okay, so why? Why do we want a resource function ever? We already have a function. It's a symbol. I've been doing this for 30 years. Don't tell me my functions aren't any good. Well, you probably don't if you just want to keep doing the same thing you've been doing for 30 years. If all you're doing is defining functions that you know how to use, and you just want to use them locally, and then there's really not any reason except that it makes a pretty looking pill-shaped blob. But the two big reasons that you will want to do this is it allows you to add metadata to your function. So all resource objects, like I've said a couple times, contain metadata that is, wraps around the content. So it can have a description. It can have additional keywords for searching, and most importantly, it can have documentation. So sort of we've been documenting our own functions a long time, and it works really well, and we have some of the best documentation system in the world. But we haven't had success in creating a system that lots of users have used to create documentation on their own. So this is sort of our first, or maybe not first, but our newest foray into trying to do that with some success. Being able to document your functions is important for your own use, really, but especially if you want to share your function with somebody else. And then the second main benefit is distribution. So once you've added this resource object and resource system layer on top of your function, you immediately have the tools to distribute it either via your cloud account, or if you think it's good for the public interest, you can submit it for publication in our function repository. So those are the main benefits. So how do you create a resource function with a rich, filled out metadata collection? And the way to do that is with what we call the definition notebook. And you can get a definition notebook in 12 doing create notebook, a function resource, but it's more fun to use a resource function to create a resource function. It's very meta. So we've published this resource function called create resource notebook that you can use even in 11.3. And so here is the definition notebook. I know at least a couple of you are familiar with the one of these that we made for the data repository. It has not been a great success. So this is a much better attempt at it, I think. So we're doing we rethought a lot from that process. So if you'll bear with me, we're going to take the next few minutes and fill one of these guys out. And we have functions like labeled and framed. There's one that we published in the function repository already called circled, but we don't have anything called wiggled. So we're gonna take a few minutes and make a wiggled. And so that you put the name of the function there, then you add a description, and this is, I think of it as sort of like a little marketing tagline. So I'm going to say add. I should have turned off my chat, shouldn't I? Add a wiggly, jiggly attitude to anything. And then we're going to say, then you just go right ahead and define your definition. So this is going to take any kind of expression, and we're going to say with wiggly equals, we'll use a dependent function. So wiggle image of rasterize of expr. And then let's check for failures. If failure q wiggly $failed, otherwise interpretation, oh, I missed an R, interpretation of wiggly expr. All right, do I need one more bracket? No. All right, so I do. And then we need to do this wiggle image. I'm going to cheat on this. I have it. It's a one-liner, but there are some options that I just can't remember for the life of me. Wiggle image of image equals that guy. Image transformation is a fun function if you've never used it. And then we'll add sort of a catch-all failure thing here. All right, so now we have our function that obviously is about to go viral. So the next step is to create documentation. So wiggled, I'm putting expr here. It was also the actual name of the argument. That's just a coincidence. I could have used anything. Let's see, displays a wiggly version of expr, which is interpreted as expr when used as an input. There's a art to writing these things that I am a novice at, and I think maybe 3 people have ever mastered it. So if you have a function that has multiple use cases, maybe there's a 2-argument form, you can just hit enter and make another one, wiggled A1, A2, and then da 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 da. So just hitting enter you can make as many of these use cases as you want. Wiggled it could take a wiggle function as a second argument, but that's for another day. So now you want to say details and options. So. Yeah. Right, right. I agree. Yeah, we want to do more like structured searching in the resource system in general. It's definitely something that's on the near-term to-dos. I think I agree. Yeah. All right, so details and options. So we want to say the result is, I should say, I know there's an hour-long talk. There's probably some other ones starting. Do not feel shy if you want to go to any of the 2 o'clock talks. Sorry? Oh, yeah, absolutely. The result is an interpretation object. You can say the wiggle function is 0.02 sine 20 hash. There we go. All right, so now we've added some notes that people need to know. Examples. So like I was saying with the data repository and all the other repositories, having examples to fill in your documentation is invaluable. People love it. You got to do it. So caption, input, output is the way to go. So caption is wiggle some text. And then we say wiggled of hi, I'm Bob. Evaluate it. Hey, it's wiggled. Let's do another one. Wiggle an image. Let's say wiggled of resource data. We'll use the data repository to find an image. There we go. Funhouse mirror style. She was cuter before, but that's okay. Let's say one here about how the interpretation thing works. Wiggle a data set. And I can't type one out fast enough, so we'll grab one from the documentation page. If it wants to open, there we go. Wiggled. And then we want to say the result is still interpreted as a data set. All right, so we got this guy. We want to show this, so we do something like all C. There we go. All right, so this is a fine set of examples. You could certainly fill out more. And this is sort of what I think is like the minimal good point to make a resource function. But I'm going to be more ambitious. I'm going to think about submitting this for publication. So I'm going to fill out some more metadata contributed by Bob Sandheinrich. And then keywords, which helps with searching. So what are wiggle, jiggle, wavy, bumpy, sine wave. Come up with anything that you think somebody might search for that should return this. Related resources would be if there was another function that was, sawtoothed version of this. That would be a related resource. Or something from the data repository. If we have like a 3D graphics of ruffles ridges, put that in here. Or the neural net repository, if there's there's a net that makes things look like Van Gogh painted it. That's sort of wiggly. So that you could put that in here. I'm not going to do any though. Links to other things. Maybe like a math world link is a good thing to do if you're doing something, sort of mathy. And then test. It's always good to have a verification test. So I'm just going to do head of wiggled of foo. This is sort of the simplest case. Oops. And if you have a published function in our repository with these tests, every time we do any kind of update, whether it's a Mathematica version or a cloud release or an update to the function repository itself, we'll run this as part of a test suite. If something goes wrong, either we'll fix it if we think it's our fault, or we'll let you know if you're using some code that's out of date. So there we have a completed definition notebook. You can put notes down here to yourself or to the reviewer. They will not be part of the resource function or the resource object. They're just something that sits in the notebook. So first thing I'm going to do is say deploy in this session only. What this does is it gives us this little result bar that has this tiny little guy. I'm not sure how well you can see that, but we'll go back to my presentation. So now we can use this in this session anywhere, range of 100. Now we can wiggle things as much as we want in this session. So we have a resource function. The next thing you're going to want to do, now that you have this nice function with metadata and documentation, is share it. So the easiest way to do that, we go back to the notebook. We say deploy publicly in the cloud. It's going to chug on that for a minute. It's mostly spending time rasterizing those examples so that we can make a good web page. And so now we have an example notebook, or I'm sorry, a web page that contains the examples from our example notebook. It contains this, and if we grab one of these things and I paste it back here, you'll see that now the resource function contains a cloud object. So you can send the URL of the cloud object to your colleagues, or blast it out on Twitter, and anybody can use this anywhere, and they'll see their documentation, and the function will just work for them. For example, my colleague Rick here, he made a resource function called birdpeak, so I can just use this. It gives me a resource function. I'm not even sure. I think this does something. Oh, that's disappointing. All right. Well, anyway, if you want more control over this thing, you can use cloud deploy instead of the notebook. What? So instead of using the button in the definition notebook, you can use cloud deploy directly. So you can take the resource function. Let me just go back here and grab that again. If I have that resource function, I can come here and I can say I want this to be in my cloud. Resource functions, maybe shared, maybe wiggled, right? So you can sort of control your cloud space that way. And also a good thing you can do, you can control permissions. So if I want to send this back for Rick, I can do, and again, he goes to read, and that will, so now instead of being public for the whole world, this cloud object is only shared with him. And since he gave me this wonderful bird with the sunglasses, I'm going to help him make some things wiggly. If we look at this, it's just like the one we sent publicly, but it's in the URL that we specified with the permissions we specified. So that's sort of a great workflow for maybe internal tools that you want to use within your company or your organization, but not published for the whole world. But maybe you make something really great and you want to publish it for the whole world. There's a button for that here. We can just say submit to repository. It'll chug on that, and in a few seconds it should give me a submission ID. And what this is going to do, there we go. So now we have a submission ID. So this enters it into a queue for reviewal. And we'll talk about that submission and review process in just a couple minutes. In addition to that button, we also have this function resource submit. You can put your resource function right in there and do it programmatically as well. How am I doing on time? Plenty of time. All right, so what should you submit? We don't want a function called never add, right? These are things I think you should submit. Things that you have always thought should be in the Wolfram language, the holes that we've had that you've forever said, why don't they have a function for this? I can write it in 10 minutes. So send that to us. Also, anything that's really focused on your domain, something niche. If you have some computational tool that's about only about orchids, right? Computing heat transfer on the leaf of an orchid. Sure, let's put it in there. It's probably never going to be something we want in top-level Wolfram Language, but it's good for the function repository. There might be 10 other orchid people, and they'll all like it. Something a little fun. We take the Wolfram Language very seriously for good reason, and I'm glad we do. When we want to put a function in the Wolfram Language, it's a long process of coming up with a concept, right? Having design, implementing it, reviewing the design, re-implementing it. It can take a long time, and because of that, we don't put silly, trivial things in there very often. We don't have Easter eggs. But for the resource function, the bar is a lot lower. So if you want something that's not so serious, send it to us. And then the rule I've been using so far is anything I've written in 10 different projects is got to get submitted, right? That means it's a good thing that's missing, and that we need to. And we hope that this will become, for a lot of functions, sort of a proving ground for something we might want to put in the Wolfram Language system properly. But for some things like that orchid thing, it'll just forever live in the function repository. All right. So that submission process. Sure, go ahead. Right, it's sort of the same naming convention as Wolfram Language symbols in general. So, no spaces or special characters, just letters. It has to start with a capital letter. It should be camel case. That's the convention. And we have when you submit something, it doesn't immediately put out there. So as part of our review, we're sort of going to take on the burden of controlling namespace. So if 2 people have something called bird peak, it's going to be up to us to choose which one is the right bird peak. Yeah. Oh, if there's one in the repository and one you've created, the one you've created will take precedence. But we have a function. You can use delete object on the resource object, and that'll clear it out. And then the next time you invoke it, it'll come from the repository. And also, each resource object has a UUID in the metadata. So instead of using the name, you can always just use the UUID in resource object, and then use resource function on that resource object, and there will be no ambiguity because UUIDs don't collide. Right. So submitting. Oh, sorry. Go ahead. All right. So there's one final sort of hurdle before any human is going to look at the thing you submitted and consider its merit, and that's having access to a publisher account. So this is basically just a hurdle we have, because getting a Wolfram ID is super easy. A bot can do it. So if you go here, all you have to you'll fill out this form. We have one of our people here will look at it. If we think you're a bona fide person that wants to do something nice for the world and not someone who's just going to send us spam and not a bot, we're probably going to approve your publisher ID. But that's sort of one little hurdle. And even if you don't have a publisher ID, when you click that button, it'll put it in the queue, and it'll send you an email saying action required. Go fill out this form. And once you've been approved for a publisher ID, then that what we call provisional submission will get moved into the actual queue for review. So that publisher ID is sort of one thing to take into account. And then the review process, there may be some back and forth, typically over email with our team if we want to make some tweaks, or we want you to resubmit with some design change. We think that it's a good idea, but it's not quite done right, or your examples are terrible. You need to fix those up. And one other thing we've considered doing, and we're not sure we're going to do this yet. We might sort of release things initially as provisional. So what this will do is it'll make a resource function. And this one is actually one I created. If you remember when we were looking at the neural net repository, there was that net evaluation function. That's this. And so it's doing the exact same thing as the example at the beginning. So instead of having on the neural net repository some 8 lines of code that's not particularly pretty, you could just throw a resource function there. But I'm not sure about the name or the syntax here. So we might sort of create these, and then they're usable by anyone who knows the name or knows the URL, but they're not really discoverable. And they come with this banner saying, don't get too attached. It might go away. So that's and we might even do some like live Twitch design reviews on these things so that the community can have input on these. It's an idea we've thrown around. Don't set your calendars yet. All right, and about the publisher accounts, we have this $publish ID. So it's not like each user has a publish ID. If you're part of an organization and you have a group of 6 people that are Mathematica users, you can have one publish ID for the whole group. Equivalent or conversely, you yourself can have access to multiple publish IDs. You can have a personal one and one for your organization. And if that's the case, you can use this $publish ID before you click that button. Just set it to whichever one you want to be associated with it, and that'll work. Or you can use resource submit, which has a publish ID option. So if you have multiple publish IDs, I don't think that's an issue for many people yet. So that's sort of the function repository and resource functions in the submission process. Yeah, Shadi. No, the publisher ID is only for submissions to the public repository. The permissions was for a cloud deployment. So that's something that is just a cloud object in your account, and there's no homepage or discovery mechanism besides you emailing the URL out to somebody, or like promoting it on your own Twitter. Or you're certainly welcome to make your own homepage using all of our great cloud tools. But yeah, so that's the permissions don't apply to the. Yes. Yeah, just like any cloud object. It literally is a cloud object, so it takes all the same options. And I was using cloud deploy of resource object, just like you would an API function or a notebook. Anything that cloud deploy takes, you can just put a resource function or a resource object in there. All right, sure, Bob. I'm gonna cut you off. We're gonna get to that later. Yeah. So, right. So, anybody else want a question on functions? All right. So, formula repository. Maybe we should put this at the beginning, but we're getting to it at the end. If we ran out of time, I was gonna skip it. So this is another repository we made that there's a public website. And it's out there to use, but we just haven't really found the right opportunity to promote it or announce it. So it's just sort of been sitting there for a couple months. So if you're familiar with formula data in the language, this is basically the same thing, but what we've added is a web interface for searching them and using them. So here we have them broken down into different categories. If we look at all the physics formula that involve one variable with angular velocity, we can choose one of these things. And what's great, like with all the repositories, there's a name, there's a description. If you come down here, there's copyable examples that you can use right in the Wolfram language anywhere. But there's also this form. So this is just a public web form that anybody can use. So let's see, 10 years. We're good at units. Angular accession. 1 radian per second squared. 10 hertz per second would be equivalent, right? Let's play with that. Initial angular velocity. 100 rotations per hour. Let's just throw some things at it, see what happens. Oh, did I get this wrong? Just hertz? No, it should be hertz per second, right? Oh, okay, it's not angular. Yeah. Hertz doesn't imply like, okay. All right, we'll just do what they told us to do. All right, so you can see we have some formatting issues now. We haven't announced this, so it hasn't really been thoroughly tested. That should have done the times. Yeah, this website's live. Feel free to use it. Feel free to report bugs like this to us. But it hasn't really been through our testing. But this is another thing that's enabled. That's a repository enabled by our resource system. So I figured I would take this opportunity to try to get some people to poke at it. So that's the formula repository. Upcoming work for our team, we want to have an API repository where basically you can submit APIs to run in our cloud that people can make requests to from any system. So you can create a Wolfram Language API that the Python users can hook up to, and they can do things they never dreamed possible. Then the big thing that people are excited about is a Packlet repository. So Bob, this is where your question comes in. So we're sort of thinking of the Packlet repository as like the upcoming big brother of the function repository. We know that people are very interested in this. No one more than us. But the function repository has forced us to make several of the tools that will enable us to build a good Packlet repository. So probably this time next year, I'll be telling you guys about the Packlet repository. If you've seen the notebook archive Stephen demoed in his keynote, there might have been another talk that mentioned it. It's part of the Wolfram Foundation, and behind the scenes, secretly, it's powered by a repository. Even though it doesn't live on the resources subdomain, it's a Wolfram Foundation thing. We've been migrating some demonstrations content into the resource system to make it easier to access it in the Wolfram language. So you can just do like resource data of demonstrations product, a 4-cylinder engine or something, whatever they're called, and the manipulate will just show up. That's the hardest part of that is migrating 10 years of content, and each case we're sort of we have to manually adjust some metadata. And at some point, we're going to do service connections in the repository. And there'll be a host of other things, devices, several. There's a long list of repositories that Bradley here can tell you. I don't know. I don't think so. No. All right. So before our Q&A, I just want to give credit to the rest of the team that's helped me with this. They're all sitting in the front row over here. Bradley, Rick, Cody, and Manu. They're also responsible. So feel free to. Has this bird stopped going on its own? I haven't seen it for a while. Oh, okay. All right. Yeah. Okay. Presentation mode. All right. So yeah. So that's the talk. And if you have more questions, feel free.